Hello, dear children, and welcome to mathematics class for class 8. Today we will be starting with a new chapter, that is chapter 11, mensuration. Mensuration, it simply means measurement, okay? Taking measurements. In this chapter we'll be dealing mainly with calculations of different measurements, okay? So in the previous class, in the previous years, that is in class 7, we have already learned about different names such as perimeter, different and area. We have already learned about their formulae, different formulae for different closed figures. Now, let's do a quick recap before we go into detail. So we already know that perimeter. We already know what perimeter is. So perimeter simply means the total length of the figure or the total length of the boundary. Let's say this is your rectangle. If this is 2, this will also be 2. If this is 1, this will also be 1. All right. So if you want to find perimeter, you simply have to add all the sides. That means 2 plus 1 plus 2 plus 1. So when you find the total length of this boundary, 2 plus 1, 3, so you're getting 6. When you find the total length of this boundary, you are measuring your perimeter. All right. So perimeter simply means the total length of the boundary. This length can be found by adding all the sides. Okay. In simple words, adding all the sides. Similarly, for area, area simply means the space inside this boundary, right? The space inside this boundary, and this area is found out. It has a different formula for different figures. Okay, the area has different formula for different figures. So we will do a quick recap. We will look at what we have learned so far. Let's organize them in this manner: shapes, and then this will be the place for formulae of area, this for perimeter. So let's look at the first one. We have already learned about square. Square, it has all the sides equal, right? All the sides equal, and its formula is side into side, that is for area. Or we can also write S into S or S square. Any of them, okay? Either of them. And the formula for formula for perimeter of square is 4 into side or 4 into S, okay? So this is the first one. The second one which we have learned so far is about rectangle. Opposite sides are equal in rectangle, right? So for area, we have length into breadth. Let's say this is your length, this is your breadth. So area will be length into breadth. Perimeter is twice of length plus breadth. We will not be going to detail for this because we have already learned about all this in class 7. Number 3, we have also learned about triangle. Triangle, okay? So this is your height, this is your base. So you will get half into base into height. And for perimeter, you simply have to add all the sides, S1, S2, S3. Let's mark them in this manner, okay? 1, 2, 3. So for perimeter, S1 plus S2 plus S3. All right? So this is about perimeter, perimeter of triangle. All right? And if you look at the next topic, that is, we have learned about circle. So circle looks like this. This is your center, this is your radius, okay? So area of circle is nothing but pi r square. R is radius, all right? And for perimeter, in circle, we do not call it as perimeter, we call it as circumference. And it is written as 2 pi r. Okay, here pi is always equal to 22 by 7, and r denotes your radius. Okay, so this is a quick recap of what we have learned so far, right? And there are many more such examples. Let's look at all of them. Please make sure that you are writing all this down. Now there's another one, that is parallelogram. So parallelogram has opposite sides parallel, right? And the formula for area was base into height, and for perimeter is simply add all the sides. Okay, I will not be writing it, just add all the sides, 1 2 3 4. You add all the sides, you get the perimeter. All right, and for area we make a perpendicular. This perpendicular line formed is your height, and this is your base. So these are all figures which we have learned in class 7. So let's look at the next type of figure that we will be learning today. The next one is called trapezium. Now in trapezium, one pair of opposite side is always parallel. Okay. Now in trapezium, let's say I have this. So this side and this side are parallel to each other. That means they will never intersect. If you produce them, they will keep going in the same, in the same path. They will never touch each other. All right. So this is your opposite sides, and this is the perpendicular, and this will be your height. Okay. And let's say that this is your base, or B, and let this be your side A. So area of trapezium is equal to half of A plus B into H. Now if you look here, A is your side, B is your base, and H is your height. So please memorize this particular formula. All right. This formula will be used to find the area of trapezium in every case. Okay. Rhombus. So rhombus looks something like this. All the sides are equal, same as similar as a square, and their diagonals, these are the diagonals, their diagonals are perpendicular to each other. Okay, so area of rhombus, this area of rhombus is found by, all right, let's denote these two diagonals. Okay, this is the first diagonal D1, this is the second diagonal D2. So area of rhombus is found by half into D1 into D2. That means half into length of the diagonals. Okay, two diagonals are there, so length of these two diagonals multiplied by half. This will give you the area of a rhombus. All right, let's move on to the next figure. The next is general quadrilateral. So it can be any type of quadrilateral, any shape. General quadrilateral. Quadrilateral simply means a closed figure with 4 sides. Okay, so it can be any shape. So let's say I have a quadrilateral in this manner, and I draw a diagonal like this. So let me mark it A, B, C, D. Now, to find the area for this quadrilateral, first I have to draw a diagonal. All right. So let's write the first step. The first step is join or draw diagonal AC. All right. This is the first step. The second step will be find the area for this triangle and then this triangle. Okay. Find the area for triangle ABC. Now to find this, I have to make a perpendicular first. This will give me the height and the base. Similarly for this, a perpendicular, this will give me the height and base. So half into base is AC into height is, let's simply write height. And for this, the second triangle ACD, half into base is same again, AC, into, let's say this is H1, this is H2, height 2. Okay? So we have two areas, area of this triangle, area of this triangle. So to find the area of this quadrilateral, we simply have to add this area plus this area. That means area of triangle ABC plus area of triangle ACD. Okay? So in the final step, area of general quadrilateral, okay, will be addition of this and this. Area of triangle ABC plus triangle ACD. So when we add these two, we get half into AC plus H1, plus half into AC into H2. Half AC is common, so I take half AC outside and this is into H1 plus H2 will remain inside. So this is your formula for general quadrilateral. This AC I can write as half into D into H1 plus H2. All right. This D will be the length of your diagonal. This H1 and H2 are the height of these two different triangles. Now for the next topics, we will simply look at the formulae which we have to memorize. The first thing we have to learn about is solid shapes. So solid shapes are nothing but 3D shapes. 3D means they will have length, height, width. Okay. What we have learned so far is drawings like this, right? Only length, breadth, side, right? But we're going to learn about 3D shapes. We have already learned about this in the earlier classes. Cubes, cuboid, cylinder, and all. All right. So we will deal with them one by one. So the first one is cuboid. Cuboid looks like a rectangle. It looks like this, almost like a rectangle. Now, for cuboid, we have to learn about the surface area. This is the formula which we will be learning about. Now, this will denote your height, this will denote your breadth, and this will denote your length. Okay, so surface area, the formula will be surface area formula is twice of LB plus LH plus BH. And this is the total surface area, meaning all the faces, okay? All the face, this face, this face, this face, addition of all the faces. And then there's another formula which is lateral surface area. Lateral surface area means only the sides, okay? Only the sides. For example, this is the cuboid. Let's say this is the cuboid. I add only this side, this. Leave out the top and the bottom, okay? So that is your lateral. We leave out the top and the bottom. So the formula will be 2HL plus B. And then the third formula, volume. Length into breadth into height. So these are the three formulae that you have to memorize for cuboid. Total surface area or surface area means all this, all the sides, okay? All the sides. This is your surface area. Lateral surface area, this one, it means the sides, okay? Only the sides. Leave out the top and the bottom, right? And volume means the amount that it can hold, okay? The space inside, this one, all right? So these are the three formulae that you have to memorize. Similarly for cube. For cube we have, this is your cube, all right? All the sides are equal, almost similar to a square. Surface area is 6s square. One square is s square. So there are 6 faces, so 6s square. Lateral surface area formula will be 4s square, okay? And volume will be s cube. Similarly for cylinder, now these are the formulas that you have to keep in mind. That's why we are just going through it. Surface area of cylinder. Your cylinder looks like this. It looks something like this. You can imagine a pipe, a hollow pipe. This indicates your height, all right? And this indicates your radius. Now, surface area is equal to 2 pi RH plus 2 pi r square. That means two circles, area of two circles, and 2 pi RH is the curved area, okay? And lateral surface area is equal to 2 pi r h plus r. So these are formulas that you have to simply memorize. Please try to keep that in mind. Volume is simply pi r square h. Okay, so these are the formulae that you have to memorize. And please keep in mind that for pi, in every case, we're going to use 22 by 7. All right, for this pi. All right, so with this, we come to the end of this introductory class for Chapter 11, Mensuration. We will continue in the next class with the different exercises, different types of problems, and we will try to solve as many different types as possible. So I'll see you next time in the next class. We will start with the exercises. So please take care. Until then, stay safe. Take care. Bye-bye.